Hello. So we are back. Wednesday, there are like 30 degrees outside. It's mad hot. Okay. So again, let's. We have a TV. We have a. I don't know what TV it is. Looks like Samsung, but I'm not sure. Anyway, the problem with this one is it's not working. It's dead. This is just a short video. Okay. Let me put somewhere this Mac. So what do you check first? You have a dead TV. What do you check first? Dead TV, yeah? First, obviously you check the fuse. Actually, I prefer to the fuse to be burned instead to be good. If the fuse is good, especially on this like a new board, you have a problem. Okay? Because the capacitor on the new boards are quite good. So let's see, multimeter, diode mode, and that's the fuse. Sorry, it's quite messy here because I done a lot of jobs today. Okay, fuse. And you can see on the multimeter it's nothing. It's nothing. It should be like that. Yeah, it should be zero. Nothing. The fuse is burned. And you'll say, why? Yes, yes. With the fuse, it's only the fuse. No, it's never the fuse. The next step, what you have to check, or maybe you have to identify the components. Yeah. So you have the fuse. You have few, small transformers or coils. Yeah. These are the input filters. It's keeping outside any interference, but also is keeping the outside clean of whatever switching is happening on this board. After that, you have the rectifier bridge here, which is transforming the AC to DC. And after that, you have a small booster. Yeah, this is kind of it's a little bit complicated to explain, but how this is working and this is switching on some phase of the AC and the other transformer is switching on the other phase, and it is more complicated. Anyway, it's about the identifying. Yeah, so this is the booster. You have the MOSFET here. This is just a simple coil. Yeah, it's a transformer. It has only one coil. You have the MOSFET. Here you have the diode, which is cutting down the things from the MOSFET. And after that, from this output, you have the capacitors, and here you have the switching power supply, which is actually working for the TV. One more thing, you have a small chopper here, transformer, and you have a chip with a heatsink. Very nice. It's a very nice heatsink. This is the standby power supply. Yeah. So when the TV is on standby, actually this it's always working, but not this one. This power supply is working only on the TV it's on. So this is working all the time, and this is working all the time, and most of the faults are here. Okay. Next step, you can check on the AC if you have any short here, and trust me, I found these kind of coils shorted. So you can check on the rectifier bridge. You have plus here on one side, minus here, and AC on the middle. So you can check on the middle on the AC, and we have no short. Yeah. After that, you have minus and plus on the side. You can check with the multimeter, minus and plus. Check that. Check on the multimeter, 0. So we have a short between plus and minus. Now the next step, what I will do, I will check on these capacitors, because if here I have the short also, will be on this side. If I don't have short here, will be on this side. So plus and minus, and it's not short. So my shorted thing is here. Okay. Like how I said, here you have a MOSFET, a switching MOSFET, and his diode. And on the MOSFET, you can check between the pins, source and gate, and drain, and look on the multimeter, 0, 0. So this is shorted. Okay. So now we know the fault. We found the fault. The fastest way to fix this. First, we need another fuse. But the fastest way is to disconnect any pin, source or drain. So let's disconnect one pin. Here we have a bridge to the transformer. What do we have on the other side? We have another bridge to the diode. And from the diode here, no, we cannot. No, we can't do it. We can't do it. Okay, let's do it on a different way. Let's take this stuff out. I don't know what's this, some kind of glue? So all you have to do, keep in mind, yeah, when you see this booster, you see this is a booster. It's not working always. Yeah. But I think on this TV it's working. So you have 3 pins. You see here? So what I will do, I'll cut the middle pin. You see the middle pin? So the middle pin is like when you disable a bomb. You can say bomb on a video. I can, yeah, it's okay, yeah, okay. It's like when you disable a bomb and you have to cut the wire. Cut the wire and you are safe. So I cut the middle pin. Let's make the fuse. We need a proper calibrated 4 amps fuse. Yes? Where is the fuse? The fuse is here. From here to here. And you see, I will never use a wire over the fuse when I have a middle of truck. So here I have a truck in the middle. I will never use a fuse from here to here because of this truck. So I know you think I'm dodgy, but I have my you know, my principle. You can be dodgy, but you have to give 3 months warranty on whatever you fix, you know. Okay, so let's make the fuse on this side. Usually I will do it on the other side. By the way, we didn't check for short again. We'll check now. Let's check for short again. So on the sides of the rectifier bridge, and we have no short. You can see on the multimeter because we cut down, yeah, the MOSFET pin. Let's test it quickly. Let me find Christian because he is 1 sec. Okay, Christian's outside is smoking. Yeah, he's vegan. He's smoking only weed. Yeah, the both are vegan, you know, the Manuel and Christian. We have to put back together, but the problem is I can't be here and there. I'll go there, yeah? Let me see if I can switch. I can. Yeah, that'll be fine. So one more time what I did. You can see the MOSFET pin. The middle pin. It's I broke that pin and now it's fine. But anyway, keep in mind. On this case, you know, you can check. So what we did, we disable this part. So we disable it. If this part, give me 1 second. Yeah. If on any way this part is communicating, you can see by trucks with anything from the rest of the board, it will not work what I did right now. Yeah. So I did check before to see if I have any truck which is coming here. I don't. I have the plus, I have the minus, and that's all. Okay, because on some TV, or not some, yeah, some TVs, not necessary TVs, yeah, you'll see also the main power switching power supply is communicating with the booster, and they are working like in sync. But not on this case, okay? So I'll go there and I will check, okay? Just wait 1 second. Yeah, I'll go there, I'll put a board and we'll check together the TV, yeah? Yeah, Christian is here. Test our to screw. Test it. Yeah? Christian will test the TV. Let's see. Yeah, you are on camera. We are looking at you. Yeah, everyone is, yeah. We Yeah, we are ready. It didn't blow up. Huh? Christian, with the screen of the camera, yeah? Let's see. Yeah, you can see the picture on the corner. Press the menu button. You have any menu button? Remote? What are the buttons? Yeah, okay. Okay, the buttons are on the back, but the TV is working. Yeah, the TV is on. How do I switch here? Okay, so that's the way how you can fix some. It's simple, it's easy, and there will nothing change. Maybe the TV will it will take a little bit more power, but nothing significant. Okay, it's safe. I never had problems. Everything is dodgy. Just replace the MOSFET and it's fine. But I'm trying just to leave my signature on some jobs, which I give warranty for them. For you, it's dodgy. For me, it's kind of normal. From my point of view, that circuit actually is nothing better. Keeping in mind, like how I said every time, you raise the complexity of a circuit, you raise the chance for that circuit to get faulty. Yeah. So on the paper, it looks like you save energy and you save the planet, but actually the truth is you don't really. Okay, so thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.